All right. Hello, everyone. This is the first part of the Lesson 2 lecture. Decision making is the topic for the week. And in this video, we'll be implementing an if-else decision structure solution. So the objectives will be to define relational conditions. We'll be implementing an if-else branching solution. We'll do that first as a plan, and then we'll implement that in code. And we'll also develop a basic test plan so that we can determine whether or not our solution is valid. And I'll be providing a supplemental video that focuses more closely and specifically on building test plans later on this week. So have a look out for that. All right, let's get it. Okay, so what I've already got kind of set up here is our decision making problems practice worksheet. So I've downloaded this from Moodle. It's accessible in the exercises folder. And I hope most of you, if any of you are actually taking the time to work through these practice problems. They really are the way to get better at and improve your programming skills. Don't just, jump right to the assignment. If you go through these practice problems, you'll get a lot of value out of them. But anyways, what I want to do here in this particular video is walk through the final question. So the last question here in the document asks us to write a program that will compute the income tax due on a taxable income entered by the user. And it says, use the following table to determine the tax owed. So the first thing we need to do is make sure we understand the problem. There isn't a lot of noise or additional details in this statement, so it's pretty straightforward. I'm just going to take this and apply it to a Word document so that we can kind of work through this in the steps that we have available. So if we were to kind of rephrase this, basically what we're saying here is we want to compute the income tax that's owed based on an entered earned income amount. Okay, so that's one way to kind of restate the problem to see whether or not we kind of understand this. Let me just zoom in a little bit here. And so the takeaway from that is that we also need the table here to determine what exactly it is that we're going to do. So in terms of just kind of modeling it quickly, really there are the input, the gathering of the input from the user, the determination of what the tax due is or happens to be, and then finally the display of that. And if we look at the table, we can see that there's not just one straightforward mechanism to determine what the tax owed is. It depends on how much taxable income was earned. So there are ranges here. Any taxable earnings up to $50,000 are basically taxed at 5% of any amount that's over the $0 amount. So 5% up to $50,000, and then between $50,000 and $100,000, there's $2,500 plus 7% of the amount that's over $50,000. So this $2,500 really represents the 5% from the previous bracket, and then finally, $100,000 and over is $6,000 plus 9% of the amount over $100,000. And so this $6,000 amount here would be the cumulative amount that was paid on these first two brackets. So we need to implement some kind of a branching structure here. Depending on what the user enters, right, as a taxable income, we're going to either apply this rule, or this rule, and then we can spit out the result. So, we could create some kind of a basic flow chart or something like that here to model what that looks like. Again, just to save time, I'm not going to go through the drawing tools, but we can basically model this problem something like as follows. So we need to capture input, okay, and then we're going to branch, okay, and the input here, if we wanted to be a bit specific, we could do that here. So this is taxable income, right? So we capture that input, and then we have a check, right? So it's either we move into bracket A, so I'll say up to 50,000, or we go into bracket B, which is up to 100,000, or we have bracket C, which in this case would be 100,000 plus. Okay, and then based on that, we determine what the tax due is, and then finally, we're going to, display the tax that is due. Okay, and so again, I'm going through this a little bit quick, just for the sake of time, but you might want to spend a little bit more time here really thinking about what's kind of happening in these branching statements. So this is a little bit different than the previous problems that we've solved, where it really was, a matter of just simple sequence, get a value, do a calculation, spit out a result. In this case, it's get a value, but now we have really, one of three results that's going to come out of this. But again, it kind of follows the same type of pattern where we get input, we do some kind of processing, and then we display some output. So that pattern hopefully looks pretty similar to you. Okay, and so once we've kind of thought about that, the next step then is to start working with our planning. So the first thing we want to do is really think about, before we get into the steps to solve the problem, let's just think a little bit about how we're going to determine what the actual tax due happens to be. What are our conditions there? So we need to think about what we're dealing with. So we know the user is going to enter taxable income or an earned income amount. I'll go with taxable income, right? So that's an input. Okay, and you might notice like the style of how I'm typing this in or how my planning is going is maybe different from time to time, and that's fine. I'm just trying to show you in these videos that, there are multiple ways to think about how you're going to solve the problem and how you want to model it. And I'm not here to mandate any one of the methods or to say that you can't use some kind of a hybrid of various methods. What's really important to me is that you're able to show me what your thought process is. If you haven't gone through the planning phase before you start writing some code, I'm not really going to understand how you got to the point where you thought you were ready to type out some code, right? You really need to spend some time thinking about the problem and to the point where you think you have a valid solution before we go and code it. And it might seem, again, like that's wasting a bunch of time, but as part of the problem-solving process, it's actually going to save you a lot of time when it comes to implementing the code. Because hopefully you've already really thought about the problem, you've thought about what the plan of that problem would look like, and also even determine what kind of a test plan you're going to implement. And so hopefully when it comes time to implement the code, there are no real issues there. The solution you're implementing is valid, and then all you're really worried about is syntax. So anyways, let's just think about what we have here. We've got a taxable income that's an input, and then we've really got these three brackets. So I'm just going to snag these from here. I've got A, B, and C. And what I want to do first of all is determine, like, how do I know whether or not I'm going to fall into any of these brackets? So I've got A, B, and C. And so what we're learning about in this lesson is how to make decisions. And one of those pieces in making a decision is determining what the condition is going to be. So in this example, we look at, well, we have a taxable income as input. And really, we're first of all tasked with determining where does that taxable income fall in terms of our table. So we have 1, 2, 3 possible or alternative paths. And if you go back to the lesson notes, you'll note in there that I mentioned the number of paths that you can identify. You're going to need one fewer decision, right? So if we have 3 paths, that means we need like 2 conditions, right? 1 less than 3 is 2. So we can first of all ask or somehow determine if the taxable income is less than 50,000, okay? And if that's true, then we know that this is the formula that we need to apply to calculate the tax that's owed, okay? But if that's not true, then we need another condition that checks whether or not the taxable income is less than 100,000. And if that's true, then we're going to use this formula. And then finally, if it's neither true that it's less than 50 nor less than 100,000, then it must be that the taxable income is 100,000 or more, right? If it's not less than 50 and it's not less than 100, it has to be greater. So we don't need to define another condition for that. That will necessarily be like the final path that we have to take. So if we define 3 paths and we've determined that the first is no good and the second is no good, we're only left with the first one, right? We don't need another conditional check to ask, is that where we need to go? So that will be important when it comes to implementing the structure. So if we want to do it in that way, first of all, it's a number line, it's continuous. So let's just look at it as a number line and first look at the first chunk and determine if the value is not in this range, how do we move on to check if it's in the next range? And then how do we move on to check if it's in the final range? And the trick here, if it is a trick, is to look in this taxable income column, because we actually have literal values that we can use to perform the conditional checks. So for condition A, it's, saying up to 50,000 is really akin to saying the taxable income is less than 50,000, right? So that condition accounts for any value right up until 50,000. Okay, but not 50,000 itself. It's not less than or equal to 50,000. It's less than 50,000. So $49,999.99. That would put us into taxable bracket A. Okay, and then we can determine here, well, how are we going to determine what the taxes do? Okay, and we can type that in after the fact. So here we just say something like, first bracket. Okay. And then we can do this, the same thing with the second bracket. So we look at this again, it's up to 100,000. Well, if we've already determined that this is not true, the taxable income is not less than 50,000, we don't have to reiterate that the taxable income is greater than or equal to 50,000. If we even get to this next condition, it's implicit that the value that was entered is 50,000 or more. Because if it was less than 50,000, we would already be calculating the tax in the first bracket. We wouldn't be coming to this second path, okay? And what I see a lot of students do in this intro programming course is they look at these brackets here and they think about each bracket as a range, and they treat them as both a dual condition, one being that the taxable income is greater than a certain amount, but also that it is less than another amount. And you can do that. It's not wrong, but it's more work than is required. Okay, we can just as we move along this number line, if we've determined it's not in the first chunk, then it must be in the next. And so the only condition we need to state here is that the taxable income is less than 100,000. Okay, so if that's true, so it wasn't less than 50, but it is less than 100, then we know that we're in the second bracket. And now finally, if the taxable income entered was not less than 50 and it was not less than 100, then it must be 100 or more. We don't have a conditional check for this. So there is no condition here. We can just simply say we end up in the third bracket if we didn't fall into the first two. Okay? I hope that reasoning makes sense. And again, take some time to think about it, talk it out loud even to yourself, or if you have a peer or someone that's available to discuss it with, bounce some ideas off of someone. You don't need to do this in isolation. And you might, come up with some different ideas that are equally valid, or at least, some different ways to look at the same problem. And it's good to open your mind to other ways to solve these problems. Okay, so that kind of gives us an idea of what our structure will look like in terms of the conditions and then the calculations themselves. So we can even just stick with this planning piece here that we've got before we go into the steps and kind of work it out a bit further. So if we think about taxable income is the input, we can, for example, identify that tax due, that is the output. Okay, so that is what we're trying to to calculate based on the taxable income input. And in the first bracket, our tax due is going to be determined by this formula that we have here. So when we do the setting for less than 50,000, it's going to be $0 plus 5% of the amount above zero. Okay, so we can talk about, whether or not we know that the value entered by the user was above zero, but for now, let's just take it as we're assuming valid input. So the zero really doesn't add anything. The tax due is really however much they earn. So the taxable income, and it's going to be 5% of that amount, right? So we can do that in several ways, but the easiest is to just determine what 5% of that is, and that will be something like 0.05, okay? So if we multiply the taxable income by 0.05, that will determine what 5% of that amount is, and we've set our tax due, okay? We'll talk about this in a moment. And so that's it, right? There's no other directions here. The calculations are pretty straightforward. The lesson isn't about arithmetic, although we need to use that to solve these problems. The lesson is really about creating these decision structures. So we do something very similar in the second bracket. Here it is $2,500. So we're going to say it's $2,500 plus, now this is the key part, 7% of the amount over 50,000. So this value is going to turn into 7, but we're not going to multiply the full taxable income by that 7%. Otherwise, we're being double taxed. We're going to be paying 5% on the first chunk, plus 7% on that first chunk and the amount that's over. So this is very important. We need to pay attention to the language. So it's 7% of the amount that is over 50,000. Okay, and so here we need to do some subtraction because multiplication has a higher precedence. We don't want to just multiply this onto taxable income. What we first want to do is subtract that 50,000. Okay, so once we've got this in here, we can double check to make sure it makes sense. So $2,500 plus 7% of the amount over 50. So here's the full amount. We subtract 50, so that leaves us with the difference, and we multiply that by 7%. Okay, I think that's going to work. And then finally, we can look at doing this for the final bracket, which is to set the tax due now to $6,000. And now we're going to pay 9% of the amount that is above $100,000. Okay, so it's very similar to bracket 2, but here we want to make sure that we're removing this is the tax paid on the first 100 grand, and so what we're trying to do is calculate 9% of the amount that is above that $100,000. Okay, and so those are our calculations. And so once we've kind of settled on this is really the meat and potatoes of the problem. The final step now would be to, let's implement that as a plan so we can create a pseudocode plan that we can then implement in our code. And you might do that as a secondary step below, but I'm just going to incorporate the work that I've just done into my actual pseudocode plan. So we can begin to work through this. So we could do something like declare taxable income, and that's going to be a floating point value, right? So income could have some change. It's not necessarily a whole number. I'm going to do the same thing with my tax due. Tax due is going to be a real number, so we need a float for that. That's our output. Okay, and we'll come back and we'll deal with these literal values in a moment. And then I want to be explicit about kind of the full plan here. So if we look at this again, we're going to calculate the tax owed, and we're going to have an income amount entered. So those are really the only two variables that I can see in this problem. And so what I'm going to do next is I'm going to display a program title, and I'm not going to worry too much about what it is, but what I am going to do is just indicate to myself that that's what should happen. So however I develop the program title, I want to show that there so that when a user starts this program, they know, oh, this is the tax due calculation program or something. It's not just a mystery why we're prompting them for specific input. Okay, and then so after we've displayed them the title, now we can prompt for input. So I'm going to ask the user now, enter your taxable income. And we're going to input that as taxable income. Okay. And so once we've captured that, now we're into our decision structure. So I don't want this to be A, but what I do want to say is implement a decision. So if the taxable income is less than 50,000, then I'm going to want to set the tax due. I don't really need this here as a comment. I want to set the tax due equal to the formula we have. And if that's not true, so else, right? So else is to say that the first condition wasn't true. I have another condition. So this is a nested condition, right? There isn't just one or two paths, there are three. And if you go back to the lesson notes, as soon as you have more than two paths, you're going to have to start nesting your decisions. And my preference is for a stacked if-else structure where I'm nesting on the false side, but you could have done this on the true side as well, and both would be valid. But anyway, so what I want to ask now is, well, if the first one wasn't true, else, then I'm going to ask another question or another condition. If the taxable income is less than 100,000, then I'm going to calculate the tax due using the second bracket formula. And then finally, if it's neither the first or the second, we just have a final else. Okay, this wasn't true, else. If this wasn't true, then it has to be this one. So we can do the calculation here. And then what I'm going to do finally is just end my if structure, something like that. Okay, so I was able to do my planning and try to figure out how I was going to get into the different brackets and the formulas, and then take that and just basically turn it right into my pseudocode plan, which I can almost one for one, statement for statement, just take and put directly into our code. Okay, and so that's, again, the meat and potatoes of really what this lesson is about. The final thing here now is to just display the tax that's due. So we could do something like display the tax due on taxable income is, and then we can put that in there, the tax due. And that's basically it. There isn't really much else to this program. We can now walk through it once to see that it covers all the steps, and then we can think about what a decent planning or testing approach is going to be. But let's just make sure we kind of walk through it and that we think we cover everything. And I'm just going to go through this kind of verbally with you. But like was shown in the first week's lesson, it might be good to actually create a table with your inputs and write in actual values and see that as you go through the steps, you're actually producing the values that you expect to see. We'll do this with a little test plan here in a moment. But for now, let's just do this, okay? So we first of all declare taxable income and tax due. We know their types, so they can hold any real numbers. We then are going to show the user a program title. So when they fire up this program, they're going to say, oh, this is the tax calculation program. Awesome. Then we're going to prompt them on the screen, enter your taxable income, which we're going to store in the taxable income variable. And then based on the value they enter here, we're going to determine which of these three alternative paths we want our program to flow through. So the first condition is if the taxable income is less than 50,000, which satisfies this condition here, then we want to calculate the tax as 5% of the amount above zero, which would be the entire amount. So the tax due is 5% of the entire amount. Awesome. If that's not true, and we want to ask, well, is the taxable income less than 100,000? So that satisfies this condition. And here again, we want the 2,500 plus the amount over 50,000, which is the difference. So we subtract 50,000 from the taxable income and we multiply that by 7%. So that looks good. And then finally, neither of these two met. The necessary path then is to set the tax to the 6,000 plus, again, amount over 100,000. So we subtract that, we multiply by 9%, and that's it. When we finally get through this structure, then we display the tax that's due. Walking through it, it seems logical. I think we've captured everything, the essence of the program. So now I'm ready to put in some kind of a test plan. And again, I'm going to put together a little supplemental video that will talk a little bit more in detail about how to identify good test cases. But the general idea is this. We don't want to just choose random values that we want to enter into our program. We want to choose values that will test what are called like the fence posts in our program. Okay, so in this particular case, or test meaningful inputs. Again, we haven't talked about exception handling, so we don't know how to deal with, if the user enters in a string instead of a float value, for example, here, and that's fine. We'll cover that in the future. But because we can get any number, we want to make sure that we're actually going through the structure in a way that we predict and can expect. So the key here, again, is to look at these literal values that we're using in the conditions. So I've got a value of 50,000 and a value of 100,000. And in order to determine whether or not this works, we want to choose test values that are around these conditions here. And we call them kind of fence post conditions. So let me just quickly illustrate why that might be. So we've got along a number line here, running along values until we hit across this 50,000. And then we've got additional values after that until we hit across this 100,000. And then we've got, additional values. And so one way to kind of look at this is to see each of these literal values as fence posts in this fence of running numbers. So we start over here at 0 and we move on into wherever. And these are the posts where as soon as we cross this threshold, we enter into a new path or flow in our program. So the key to choosing good test values is to look at these numbers, and we want to choose a value that's on this side of the fence, a value that equals the fence post, in scare quotes as it were, and a value that's on this side of the fence. Okay, and then finally this value, and then a value that's on this side of the fence. It makes no sense to test input values of 10 and 100 and 50. Those are all on this side of the fence, as it were. So they all test the same condition. Okay, but we do want to choose a value that's on this side, equal, and greater. And then the same thing here. The greater value will be the less than for 100,000, 100,000, and greater. So in this example, if we wanted to create a test plan, let's just insert a table here really quickly. So we're going to have input values, and we're going to have our multiple test cases. So we have 1, 2, 3, 4, 5. So we'll have 5 of these. So I'll go into 6. That should be fine. Okay, and whatever. We'll dress up the table a little bit. It's not super important. Oops. Just merge these and just call this test plan, and then we'll have our input, and then our expected, and then our actual. Okay, I've got one column too many, so let's delete that. Well, that didn't do what I wanted, but it's besides the point. Oops. Merge. Test plan. Okay, so inputs. Let's try something just less than. So let's try 49,000 and some change. And we'll use 50,000. And we'll use something bigger. So this is between 100. We need one more row. So we'll have 100,000. And then we need something greater than that. It doesn't, again, really matter. We could go with, oops. It could even be $1, but I'll do it at the $1,000 mark. And then here, we'll split the difference. We'll use 75,000. Okay, so these are not just randomly chosen values. Okay, they're values that have chosen based on the conditions that we have. So less than 50, 50, greater than 50. Less than, but greater than 50. Less than 100, 100, and greater than 100. And then we would run through what we think our calculations should be and then test those actual values as we run our program against these expected ones. So we could just pull up a calculator and we could come up with our test values, right? It may seem crude, but this is what we kind of expect to do, right? Again, you're wondering, why aren't we programming? This is a programming class. This is all important. This is a part of the process. And again, in my mind, is the most important part. It doesn't serve us to go start cutting code before we know that we have something that's going to work. So we want to have the plan in place, the understanding of the model in place, and then even, yes, some kind of a test plan in place so that when we're finished coding it, we can submit it and feel pretty confident that, hey, our solution is valid. It produces the results that we expect. So if I enter in $49,999 and we multiply that by our 5%, I'm going to expect it to be, of course, right under 2,400 or 2,500. So that's what I'm going to expect here. So 2,499 and 95 cents. And so now when we run our program, we're going to get an actual result display. We can check, does that match the expected value? 50,000, I would expect that to be the $2,500. So we don't need to do really any work there. And again, these are real values, they're numeric, so we want to include the decimal precision. And so now we have 75,000. So 75,000 is going to be $2,500 plus the amount over 50. So that would be $25,000. And we're going to multiply that by 0.07. And then we add that to our 2,500. So I would expect on $75,000 of earned income that we're going to be paying $42.50 in tax. Okay, and then here again, $100,000. I would expect that comes to the 6,000. And then finally, we have 6,000 plus the 9% of 1,000, which we'll just put it in because why not? But it should be like $90. So $1,000 times 0.09. There's the $90. So I would expect this to be $6,090. Okay, didn't take a lot of time, and like I said, now we have some values that we can use to test our actual program once we create it. It is only now at this stage that I'm ready to go to Visual Studio and start writing the code. Okay, again, I know many of you are going to feel like this is a waste of time, or you're just going to feel so anxious to get to writing the code. You'll think, well, I'll just solve it all at the same time. I just talked this at you, and it took just over 30 minutes. But when I go to write this code now, I know exactly what it is that I'm going to code. If I have any problems or trouble and I need to go to my instructor for help, I can show my instructor exactly my plan and my code. And now the instructor is going to be able to tell me, hey, the code you've written doesn't match your plan. Or maybe you're just implementing something backwards. If you come to me with questions about your code and you can't show me the plan that you're using, that's the basis of your code, all I'm going to be able to tell you is, well, the code that you've written does exactly what you want it to do, because all I can see is the code. I have no idea what you actually intend the code to do. I can only confirm that it's doing exactly what you've typed in there. So having a plan to show me or to show your instructor is also going to serve you in cases where you need some additional help. You'll find that the instructor is much more helpful, not because I don't want to be, but because it's easier for me to be helpful if I have an idea of what it is you're trying to do, and I can see what you're actually doing, and then determine if those things are congruent or not. You know, if all I have is what you've done, all I can say is, yeah, it looks like it does exactly what you typed. So I don't know if that's right or wrong. I don't know what you mean. So please, don't take it for granted. Do the planning up front. It's going to help you, again, become a better programmer and problem solver. But also, if you need help, it's going to make it easier to explain your case. So let me remove this for now. And I've got Visual Studio running. Again, I'm on my Mac, But if you're on your Windows machine, you know the process to create a new project. It's no big deal. So I'm going to create a new console application, and I'm going to call this one lesson 02 if else. So I know what that is and I can go find it later. And I'm going to create that. Okay, great. And I'll just shrink it up so I can see my plan over here. And there we go. Okay, so again, got our scaffold, we're ready to go. I'm not left wondering at this point, what to do. I know exactly what I'm going to do. Here's my plan. So I can just get to business and start writing this in there. Console write line is going to come into play quite a bit. So what I like to do is just take this and I'll cut it, Control X or Command X, and then I can just paste it in all the different places that I need it. So looking at my plan, first thing we're going to do is declare some variables. So I've got some doubles. Again, my pseudocode uses float, but that's because it's just a plan. I should be able to implement this plan in any programming language. I happen to be implementing it in C#, so the type for float here in my plan is double in C#. Okay, I know that's going to be confusing at first, but I want you to get comfortable with the idea that there are different languages and they have different defaults and different syntax, and being able to take a generic plan and implement it according to the rules and language guidelines of the language you're using is very important. Okay, so double, again, it's capital T taxable income in my plan, but we want to use camel case naming conventions for our variables in C#. Okay, so I've got a couple of these variables, and then tax due is also a double. Okay, and now I'm going to display, here's where my write line comes in. I'm going to do a couple of write line statements to display a program title. And again, you might have seen this in a previous video, a supplemental video. I like to just use equal signs or asterisks or whatever. You don't have to get fancy with it, but like I said, I like to. So I'm going to do something like this. We'll use equals, symbols. This is my idea of having a little bit of fun. And then I can, yeah, we'll just paste it here. And then, I'm just going to call this the tax due calculation or calculator. Taxes, how about this? Taxes due calculator. And I need one more of these. Okay. Looks good. Taxes due calculator. I've got a blank line here, right line, so to separate that from the rest of my program. So going back to my plan, display the program title. Done. Next, we're going to prompt for our input. Prompts are going to make use of not write line, but write. So we can do that. It's console.write. Enter your taxable income. And we're going to store that in our taxable income variable. So again, here it's a double. So we're going to parse that double from the console, and we're going to read in a line to do that. Right? So now we've prompted for our input. Now we're ready to implement our decision structure. Okay, so this is the new part. So if we specify our condition, our taxable income is less than 50,000, then we know we're going to do our calculation as tax due is equal to this. So tax due is equal to our taxable income multiplied by 5%. Now, if that's not true, else we have another condition, and that is if the taxable income is less than 100,000. Okay, the key here is to combine these. If we had one if followed by not an else, but another if we had entered a value of 5,000, well, 5,000 is less than 100,000, so it would fall into this condition. So it's important that we have this as a chained or total structure to make sure that only one of these three paths will be followed, and that's how we implement this. So if this is true, we do something similar. We say the tax due is equal to 2,500 plus the taxable amount. Now this is where we have to do some parentheses because of order of operations and precedence. Oops. And so it's the taxable income subtract 50,000 because we want the amount that's above 50,000, not 550. And then we're going to multiply that by 7%. Okay, and then finally, if neither of those are true, we have a final else where it will be $6,000 plus the amount above 100 times 9%. Okay, so we can look at our plan, we can check our code, and we can see that those two match. Okay, looks good to me. Fantastic. The final piece now is to display our output. So we use a right line. And here I'm going to do a little bit of formatting. So there is a document posted in week 2. I hope you've looked at it. It talks a little bit about, it demonstrates how to format your output. But I'm going to use a string interpolation to do simple currency formatting. So my output string, I want to use interpolation. And here in our plan, we said the tax due on the amount, the income is tax due. So I want to keep that here. So the tax due on, and then here we use the interpolation for the taxable income. I'll just stretch this out so we can see it all here. Is the tax due. And a simple way to format these values if you're using interpolation is to just use the colon. And so again, if you have a look at that formatting output PDF that's posted on Moodle, it will show you a number of different formats you can apply. But currency is pretty straightforward. We can just say, yep, this is the value I want, colon, I'd like to format it as type C, which is currency. And that will apply the current locale currency. So my current locale is Canada or Canadian English, so it's going to use that as the format. If you were in Great Britain or something, then it would format it with pounds instead of pound sterling instead of the Canadian dollar or what have you. But that's a simple way to get currency formats. If you need other number formats and alignment, we'll cover that in other lessons, but the output formatting document covers that for us. Okay, so that's the full kind of program. Now you might want to put some comments in there to explain kind of what's happening. Maybe here, you might want to include a comment that describes the table we've used or something like that. But one thing I definitely want to see, again, especially for your assignments, is up at the top to include a summary comment. So here we can say that the purpose of the program is to calculate the tax due for an input taxable income, right? That's how that goes. And you could specify more details about the process of the table, etc. At this point, if you liked. At a minimum, I'd also like to see the author. So you type your name in there and the last modified date, which will be, in this case, May, what's today, the 12th. Okay, so now we have a little comment at the top that says, okay, calculate taxable income. And yeah, we'll just do it here. Something like there are 3 brackets. Oh, and we'll just use the language right from the document. Up to 50,000, up to 100,000, and oops, let's say 100,000 or more. Okay, and yeah, I won't put in the details, but again, just some information in the comment that describes what the program is about. Okay, very neat. We've got everything aligned, formatted, looks great. Now I'm going to run this. So at this point, you might say, I'm done, I'm going to submit it. But we're not quite done yet. What we want to do is run the program and put in our actual values. Let's do the comparison to make sure that we actually see what we expect, right? This is the important part, the testing piece. So we'll come back and we'll run this. And So here's our program title, enter your taxable income. Our first amount is going to be this 49 and some change. And here it says the tax due, 2499.95. Again, notice how we use that format, that :C. We actually have a $sign, the comma, the thousands separator, and we didn't have to do anything fancy with number formats or whatever. So if you need to format currency, a C is the easiest way to go about doing it. So we can check that output value and see, does that match our expected? And it does. So that's fantastic. We've effectively passed that test case. So that's great. So we'll close this down, and then we will run through our remaining values. Okay, now in later courses, you'll hopefully learn how to automate testing. But in our simple console-based applications here, the best we have is actually run the program and do some inputs. So that's kind of what we're stuck with. So let's enter in the $50,000 value. Tax due is an even $2,500. Again, that's what we expect. So fantastic. We've 2 for 2. Right? And we just kind of continue going through this. Now you might say, hey, if it worked for those two, it's probably going to work for everything else. And yeah, maybe, maybe it will, maybe it won't. It's hard to know. So 4250, again, that matches. I would recommend, for the additional 2 or 3 minutes, however long it takes to test your program, it's worth it to do it than to risk having some kind of a typo somewhere below, because we haven't tested the 100,000 condition yet. And if you were to just go this far and then submit it, maybe you did something wrong here and you haven't captured that. And that would be a bad thing. So you don't lose some marks because you spent all this time planning and coding, and then only to not check it, and then a minute of extra work costs you some marks. Okay, and then the final value was 101,000, and we got 6,090. So awesome, right? This is great. All of our test cases passed. Our little test plan was good. At this point in time, I would feel confident saving this and submitting it for final grading. And for me as your instructor, that's the best too, because programs that work 100%, they're the easiest to mark. I look at it, it's got all the requirements, it's formatted nicely, we've got meaningful variable names, and everything is accurate and valid. Like I'm going to grade it by looking at it, it's done. It's when you haven't done the testing and the planning and your program doesn't work quite right that I have to spend extra time looking at, well, what did you do correctly? Where did you make your mistakes? How can I give you feedback? So yeah, spending time does 2 things. One, it enables you to create a program that's going to get you or earn you higher grades, and it's also going to save me time. So, if you want to make my life terrible, write terrible programs, I guess. But yeah, put the time in up front, do a good job, and everybody is happy. So that's, again, kind of our full run through. So we managed to get through that in under 50 minutes, which is pretty good. But again, I just want you to see what the full walkthrough looks like. And I'll do this again once more in the second part for lessons 2 videos. So in the next problem, we'll tackle a solution that can be solved using a switch statement. And I'm going to go through the exact same process that we just went through in this one. So we'll start with the problem statement. We'll restate the problem. We'll model it. We'll identify the guts, the workings, the formulas that we need to implement. And then we'll create a plan, a test plan, and we'll code it. And again, I really encourage you to work through these practice problems. Don't just jump right to the assignment. Put the time in. You're going to be writing more complex programs later in this course. The more practice you get with these earlier on ones, the easier it's going to be and the less trouble you're going to have with the more complex problems that we're going to see later on down the road. If by the middle of this course, you've only created 2 or 3 programs, that's not nearly enough. I would like to say by the end of next week, you should have gone through and created at least 10 to 12 unique little programs. Just trust me on this. You will have a much easier and more enjoyable time with the program, the course, if you spend the time doing the work now versus trying to get it all in later and catching up. It can be very difficult. So that's it. I'm going to leave that there for you all. It's recorded, so please feel free to go back and review any pieces. Um, oh, no, I'm signing off, but I don't want to sign off. There's one last thing. So to keep this under an hour, which would be perfect, what I want to do is I want to address these literal values. I'm glad I caught myself. I made a note. And there's also a challenge I want to put to you, which I'll bring up in a moment. But yes, so while this is valid, there is something that we can do better, and that is to address these literal values. Okay, now it's not that the literal values themselves are necessarily bad. It's that they could make it difficult to maintain this program into the future. And so what we would like to do typically is wherever we see these literal values, we want to replace those with constant variables. Okay, and a constant, if you've gone through the reading, is really just a variable that can be assigned a value initially and then can never be reassigned another value. And we use a different naming convention for these as well. Now, this is one of those programs that's kind of a pain because there are so many constants for us to create. But again, the idea here is that it would make your program more maintainable, and I would argue somewhat easier to read if we had meaningful values. Right now, this number, 50,000, isn't meaningful. If we renamed this to bracket 1 threshold or something, now it's clear to me that, if taxable income is less than, the first bracket threshold or something like that, or first threshold, I know what that means. And I don't have to read that somewhere else. So to implement these as constants, we basically identify these literal values and then just identify them and create them at the very beginning. So this is something, again, that I should have done here in the planning stage, but I wanted to get through the work. But again, you whether you do it at the planning stage or you do it now, it's something that I would like to see you implement. So we can declare, constants at the beginning here by using the const keyword. So if we just type in const followed by our type, so in this example, we could use this as a double. It happens to be an integer value. So, if you think the taxable income threshold might include change, you could do that, but I'll just define it as an int for now. And I'm just going to name this first threshold. Does threshold get two H's? Oh, I'm so bad at spelling. Let's just do it like that for now. Okay, if you declare that constant, or let's do something. Let's use a word I know how to spell. Bracket. Okay, if you define a constant but you don't initialize it or assign it a value, it's going to tell you that there's a problem. Okay, and the problem is if you define this, you can't assign it a value later, which basically makes it useless. So what we have to do is also assign it right straight away. So the first bracket is going to be 50,000. So now my red squiggly goes away. It's no longer a problem, but I'm not using it anywhere. So we can go ahead and now wherever we see that 50,000, I can use that first bracket constant, right? So if the taxable income is less than the first bracket, then we're going to calculate it this way. And then down below here, the taxable income on 100 grand is the taxable income subtract the first bracket and then multiply by 7%. Okay, again, if first bracket doesn't make sense, or you could think of a better word, first threshold, first limit, you can make it even longer. That's totally fine. But the point here is that in the future, if I needed to change that, as governments do, let's say we want to increase the amount of tax we're collecting, we might decrease that first bracket to 40,000. Well, it would be easy for me to just come here and replace this value like this, and now all of a sudden my first bracket is only up to 40,000. And it's going to correctly use that value here in my condition, and it's also going to correctly take that value away from my taxable income amount. And I don't have to make two changes anymore. I can just make one. So this is one of the values of including constants in your code. So we would just continue doing that for the remaining literal values. Okay, and I might just leave that as the exercise piece for this little exercise for you to do, but that's kind of how that works. And then we would do the same thing for these taxable rates. So I might have first rate as 0.05 and second rate as 0.05 and third rate as 0.09, and using those constants in every place that we see literal values. So as an exercise, I would leave it to you to define constants for these remaining literal values use them in your program and ensure that you still get the same results here at the end. And one final exercise that I would like to put to you as a challenge in this particular program is we haven't dealt with the idea that the user might input a value that's a negative. Okay, so we're assuming they entered 0 or more, but there's nothing preventing a user from entering negative 10,000, for example. Okay, that's not an exception. We're inputting a double value from the console, and negative 10,000 is a valid value. So if the user were to do that, we don't actually want to go ahead and calculate taxable income. We don't want to say, the government's going to owe you money back because you lost a pile of money or something like that. So the additional challenge I would put to you in this particular program is to, before we do all of this work, perform a check to make sure that what the user has entered is a valid taxable income amount. Okay, and what I mean by that is you only want to calculate the tax due if the amount that the user entered is a valid taxable amount, 0 or more. So think about what that means and how you might add to this structure to take into account a negative value. And remember, that would mean you go back to your test plan here and you would have to include another input value that's a negative. And then what would you expect to see, and then what is your actual? So that will enable you to kind of go through this testing piece that we've seen and then also apply some changes to your plan and also to your actual code. It seems like a very simple change, and in a sense it is, but it may be difficult at first for you to try and implement. So now that's it. We're finished up with this particular video. I will see you in the next one.